This video is going to show you how to do the basics of in behavior. So the first thing I would know if I was approaching in behavior would be this right here. And essentially they're going to write like as x approaches negative infinity or something, or positive infinity. You just need to realize that they're saying if I go left or if I go right on the line. So you'll see what I mean. Let's just dive into some examples. Imagine you had a linear function. The teacher's probably going to say, okay, if I go to negative infinity on my x, what does the in behavior look like? Well, what they're really telling you is here's negative infinity on your x. So really they're saying if I go left, what does this line do? And that's when you need to look at this and be like, oh, okay, the arrow is pointing down. Well, you're saying what does the line do in terms of y values? If it's going down, it's going to go down to negative infinity on your y. So my answer here would be negative infinity. Then they're also going to say, okay, well, what about the other way? What if I go to positive infinity? Positive infinity on your x is over here. So really, that's like them saying, if I go right, what's the line do? Well, if you go right, the arrow is pointing upwards. So it's going to go to positive infinity on your y. That is probably the most basic in behavior example I can think of. It gets a little bit trickier than that, but not much trickier. So let's see another example. They don't always have to be going opposite directions. Sometimes you'll see a function that looks like this or something, and they'll ask for the in behavior of this line. Well, same thing. If x goes to negative infinity, so if I go left on this line, what's my left portion do? It goes down to negative infinity. And if I go right to positive infinity on my x, what does this line do? It goes down to positive or to negative infinity as well. So they don't always have to be different answers. They don't always have to go opposite directions. Sometimes they'll go together. Again, that's another very simple example. Let's look at a couple more. Some weirder scenarios they might try to trick you with. Here would be one example of what I'm talking about. Sometimes you'll see something like this, and there will be like an asymptote here. We'll say it's at y equals 2. Okay, I would still approach this problem the exact same way. So I would look at this and say, okay, if I go left on my x, so the left portion of my line, what's it doing? It's pointing up. So it's going to go to positive infinity on the y's. Where they're trying to trick you is on the other side, as x goes to positive infinity. So if I go to the right, what's my line doing? It doesn't go up, it doesn't go down, it levels out on the asymptote. So your answer doesn't always have to be positive infinity, negative infinity. No, if there's an asymptote there, if there's a horizontal asymptote, your line is going to level out there. And so my answer here would be y approaches 2. It approaches that asymptote. Okay, one more kind of unique situation you need to be prepared for where they might try to trick you would look something like this. Doesn't always have to be a horizontal asymptote. Sometimes they'll give it to you with a vertical asymptote like this. We'll call this vertical asymptote x equals 1. So if this happens, then when you go to write in behavior, this first part here, you can't say as x goes to negative infinity. That would be incorrect because x cannot go to negative infinity. It's not in your domain. This left section of line stops at that asymptote. It can't go past it. So the in behavior here would look like as x approaches 1, that asymptote, what does my line do? Well, as it approaches 1, my arrow is going down, so y would be approaching negative infinity. And then the other part would be kind of the same, so the same as before is what I mean. So this part right here, as x goes to, well, this arrow is not restricted by an asymptote, so x can go to positive infinity. That's part of my domain on this side. So as x goes to positive infinity, this arrow is going up. So my answer would be y approaches positive infinity.